Okay, so you are able to see the screen?
Yes.
Okay. Okay, so let's start. So I will be starting from the, so what about your knowledge? I would like to know more about you first, like basically about your skills and what you have, the primary skills you have. Okay. And then I will go further. Okay. So I want to know, right, the Linux skills, right? What you know about in the Linux, like commands, okay, shell scripting, okay. So just you have already some knowledge in the Linux shell scripting. Second one is any knowledge in the cloud, any cloud, right? AWS cloud, Azure, if you have done anything in the past, okay, or GCP cloud. And next is uh, any big data related concepts knowledge like Hadoop, Spark, okay, if you have already knowledge, okay, and Linux cloud and Hadoop Spark, okay. And what about the Python and SQL? Okay, so I will go one by one. I will give my introduction first, okay. And my name is Arvind, and I have total 18 years of IT experience and 10 years in the data engineering. Okay, so I'm working for the healthcare client in US, okay, in data engineering. And I'm going to cover the entire syllabus of data engineering, right? We have from the starting from the on-premises to the cloud, okay? And if you have guys knowledge in the DevOps also, so you can tell me any DevOps tool, okay? So let's start one by one, okay? So just you tell me you have knowledge in this, I will note it down. Better to, I will, okay, just okay, I start first. Who will going to start first? Harish? Because I don't know who are the like management guys and okay. So you guys can
Yeah.
start.
So, hey, hi, Arvind. Myself, Harish Sana, and I don't have any knowledge on Linux commands or cloud, big data, Python, or SQL and above. Uh, Basically, I have 4 years of IT experience, and I work with Uber client. Basically, I work with a scale AI tool, but this Uber's internal client, and I don't have much knowledge on this stuff. Basically, this is a new for me to learn big data stuff.
Okay. So any knowledge in the Python, SQL, any one of these skills?
No, with Linux commands, I know basic commands, Linux, like
Hmm.
to check the list of files, like ls commands, use commands to
Okay.
create the
Okay.
files,
Hmm. 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 Okay.
to read the file, the basic commands I know.
Okay. Okay. Fine. Yeah. Who will be going next?
Hey Ivan, this is Manish. Um,
Hmm.
yeah,
Hmm.
so on the Linux skills, I don't have much knowledge on it, but on the cloud part, I have AWS Cloud Practitioner, this thing. So
Hmm.
where I got some knowledge on all the services of AWS.
Okay. Okay. AWS cloud. Anything else?
Uh,
Python, SQL.
yes, I do have 4 years of experience in data analytics, but more of Power BI and SQL.
Hmm.
Um, So I don't have much depth knowledge on big data stuff, but definitely on reporting tools.
Okay. And Tableau Power BI.
Yeah,
Yeah.
Tableau, Power BI, SQL, SS. I
Okay.
mean, SSIS, I'm not sure, but yeah.
Okay.
And during my graduation, I have Python knowledge, but I don't have extensive knowledge on Python, but I can
Okay.
manage.
Okay. Okay. Yeah. Thanks, Manish.
Yeah.
Yeah.
Hello, Arvind.
Hi.
I'm Ridila.
Hmm.
So basically, I have around 3 years experience in product management and project management background.
Hmm.
And coming to the skills, I do not have much idea about Linux or cloud or big data, but I have done my master's in data analytics, so I have a good idea on Python and SQL and some other reporting tools like Power BI, Tableau. and other project management tools.
Okay. Okay. Thanks.
Thank you.
Yeah. Hi everyone, this is Narendra,
Yeah.
and I have nearly 5 years of IT experience, and of which 1.5 year is into Azure data engineering, and I'm familiar with Azure Cloud and some basics of SQL Python, which is for Databricks part, and coming to the Spark and all, I have experience only with the Databricks, only up to Databricks, not the on-prem part.
On-prem. Okay. Got it. Got it. And cloud one, any experience in the cloud?
Cloud,
DevOps.
cloud only
Azure
Azure.
cloud only. Okay. Okay. And
Yeah,
DevOps.
DevOps coming to Azure DevOps,
Okay.
it's only Azure DevOps.
Like pipelines, right? CI/CD
Yeah,
pipelines or those.
CI/CD pipelines.
Okay. Yeah. Thank you.
Yeah, hi, this
Hi,
is
Arvind.
Jayant.
Oh,
Sorry.
yeah, Jayant, continue. Continue, Jayant.
Yeah, thank you. Hi, this is Jayant. I do have experience of 2.66 years experience in Cognizant as a AWS support engineer. There I have deal used some of the basic Linux commands and AWS services like S3, EC2, and ECS. Yeah, and there are some operation tools and the monitoring tools like New Relic, Splunk.
Okay. Splunk.
Yeah.
Yeah. Those are the
Yes.
alerting tool, right? New Relic.
Yeah, exactly. Yeah. Yeah.
What about
As
any
far
programming background, Python, SQL query,
no, I don't have any
DevOps?
experience on
Okay.
SQL and
And
no.
anything about big data, Hadoop
Uh,
fundamentals?
no,
Okay.
not much, Arvind.
Okay. Okay. No problem. No.
Yeah.
Thanks.
Thank you.
Hi, Arvind. Myself, Durga Srinivas. I had overall 3.5 years experience.
Durgesh, what name you say?
No, Durga Srinivas. Yeah, you can do it as Srinivas. Srinivas.
Okay.
Yep. I had like overall 3.5 years experience in ServiceNow and MuleSoft.
Okay.
ServiceNow. Yeah, ServiceNow and MuleSoft. But I don't have any knowledge in the data engineering platform. So,
What about
but I had
any
little bit
cloud?
knowledge on the
Okay.
no, I never touched in this background, but I had little bit knowledge on the SQL and the basic commands on the Python.
Basic.
That's it.
Basic. Okay.
Yeah, that's it, Arvind. Thanks.
Thank you.
Hi, Irvin. Myself, I'm Sunana, and I have close to, more than 6.5 years of experience as pre-sales and management vertical. Then I do have basic knowledge in SQL and basic commands of Python, little in Power BI and Visio.
Visio tool, right? The designing tool, right? Visio.
Yeah.
Okay. Any knowledge experience in the cloud, DevOps?
Non-technical.
Mhm.
I come from non-technical side.
Okay. Okay. Fine. Okay. Yeah. Thank you.
Hi, Arvind.
Sure.
Monica here.
Yeah. Hi, Monica.
Yeah. So actually, I'm new to this technology. Previous experience, whatever I have, I'm into HR recruitment.
Okay.
Yeah. So I just know basic into the Power BI.
Okay. No programming anytime before, right? In the education, right? You have done C, C++, Java, anytime.
No, Arvind. I'm very new to the coding part.
Okay. Your effort will be more, right? Because
Yes,
you are
yes.
coming completely different background. Okay.
Yeah, yeah.
Okay. Yeah. Thanks.
Thank you.
Hi, Arvind. This is Prem Sagar.
Yeah. Hi, Prem.
Yeah, I have 2.5 years of experience as a production support engineer.
Okay.
So I have a production support engineer.
Production
I
support.
worked in,
Yeah.
yeah.
Mm.
I have a good knowledge in Python and SQL.
Mm.
I have known like Linux commands, like frequently used Linux commands, and basics in cloud like EC2, S3, basics in cloud AWS. I have I have seen a course regarding big data, so I have known basic of big data Hadoop architecture.
So if I say like you are familiar with the Hadoop Spark concepts,
Mm,
right? Not very
Yeah,
deep practical, but
y-
conceptually you know.
yeah,
Okay.
yeah.
Okay, fine. Yeah. Thank you.
Yeah.
Hey, hi, this is Kranti.
Yeah, hi, Kranti.
Yeah, hi. I have like a 3 years experience as like a data engineer.
Okay.
So worked with the most of these concepts like Linux commands in my like vast experience and I good knowledge on AWS. Previously, I did an associate developer certificate on AWS.
Mm-hmm.
Good knowledge on Azure technology as well. And much familiarity with big data concepts like Hadoop, MapReduce concepts, and Hive tables and everything.
Mm-hmm.
And strong knowledge on programming as well, like most of the Python libraries like NumPy, Pandas, and TensorFlow and stuff. And coming to Spark, like knowledge on PySpark, not a
Mm-hmm.
Spark like a coding part, and like Python as well, as I said. And coming to the SQL, I have like worked with the Teradata tables, like tables creation,
Mm-hmm.
complex joins, most of the joins conditions, and I worked on MySQL and PostgreSQL as well, like in my previous experience. And I'm also involved in like a COVID-19 project for creating custom new tables from the scratch. So and involved in creating Angular dashboards as well,
And
custom
DevOps,
dashboards.
DevOps, any knowledge in
Or
the
DevOps.
DevOps too?
No knowledge in the DevOps.
Okay. So what you attract like to learn, right? Because already you know this much of thing, right? So what you think like is still you have to learn something
Yeah,
different which you don't know. What do you think?
yeah. I want to learn like as I said, like mostly my strong knowledge is on Python and SQL. So like, but the main the I just want to know like how like real time works, like how design like scalable workflows. That's what I want to learn in the practical time. As I said, like I worked only for 3 years, so most of my work like involved in like SQL
Mm.
statements and Python, and so for a couple of times I worked for the Spark, and out of my interest, like I learned data certification and like learning other other stuffs related to big data analytics.
Okay. Okay.
So like I just like I'm expecting like more hands-on experience and so in-depth knowledge how this
Mm-hmm.
end-to-end
Yeah.
workflow
Mm.
works.
So that is true because everything is not used in the project. Because if I say if 20 technologies, 20 tools are there in the big data, so all 20 will not be used, right? Because there will be few tools will be used in the project. So other rest of the tools you have to prepare your own and you have to do some proof of concept, right? Project, right? Some small POCs. So that will give you the learning. So we should not always depend on the project, right? Like, okay, we are just thinking, okay, whatever is coming in project, we will learn that. So that will not give you the complete learning. So complete learning you want to do, you have to do your own hands-on, you have to do practice and coding, right? So you have to spend more time other than the project, like whoever already working in the project. Okay.
Yes,
Yeah.
yes.
Okay. Anybody else is left?
Yes, hello Arvind. Hi.
You done all? So,
No, hello Arvind.
yes.
Yeah,
Sai Teja.
yeah, hi Arvind. So I'm Teja. I had an experience of 3.5 years in Amazon as a data specialist. So I'm good at mainly I used to work on Excel. So I'm good at creating macros and everything, all
Mm.
the Excel formulas and everything, and I know the basics of SQL and Python. That's
SQL
it.
and Python. What about
Yeah.
your knowledge, anything in the data engineering side? Hadoop?
No.
And cloud
No,
side, anything in the cloud?
no, Arvind.
Okay. So you are properly, you have done the like data analyst role, right? You have done.
Yeah, yes, exactly.
So your background is good, right? You already have SQL Python. That is a key pillar for data engineering because
Mm-hmm.
SQL Python is a two common tool in the data analyst and the data engineering. But
Okay.
data engineering is a more than the data analyst because data analyst is more concentrate on the SQL Python coding. But when we
Okay.
go to the data engineering, we have to learn cloud, DevOps, we have to learn Hadoop, Spark, NoSQL, lot many tools are there. Okay.
Yes.
So,
Yeah.
so it is like you have a background, that is a good part, but you have to learn more on the data engineering side with the new tools, right?
Yeah,
Okay.
sure, Arvind. Thank you.
Anybody else?
Hi Aditya, this is Karthik.
Okay, Karthik, yeah, hi.
Sorry, Arvind. Like I worked as a GIS engineer for 2 years.
Yeah, yes, engineer. Okay. Hmm.
Uh, I don't have any knowledge in Linux and big data,
Hmm.
but I have I have great knowledge in Python and SQL.
Okay.
And coming to cloud, uh, I'm good at EC2, S3, like these things.
Okay. So Python, SQL, and I say little cloud knowledge. Okay.
Yeah,
AWS.
yes, yeah.
Okay. Yeah, fine.
Thank you.
So all done. Okay. Okay, so I come to know in this group, right, majority of people like non-background and some people they have uh, like intermediate knowledge and some having like proper data engineering knowledge. Okay, so it's like a mix of all, right? So, but you know, right, I'm going to start everything from the scratch. So you have to keep in mind, right, because if somebody is having a knowledge, so it will be like I know a lot of concept you will feel like these are the easy things and these I know. So, but you have to what I want to make you understand, like everybody will be going in the same path. I will be starting from the basics, but I will go to the advanced also. Okay. What materials I have, what documentation, source code, everything I will share, videos I will share through Classroom. I will prepare a one Google Classroom link and you guys have to join Google Classroom link. I will paste in the WhatsApp group chat. So you have to join that classroom link. Once you join that classroom link, so there is a class work, right? You will see there the recording materials, okay? And there is a source code, right? Anything source code we are using in the class during the class source code and any PDF documentation material, okay? So these all materials I will share, but you have to properly utilize those things and I will assign the assignment every each topic. Like suppose I start first the big data Hadoop concept. Okay. So Hadoop commands I covered. So I will create a one assignment and everything will be managed through the this classroom. Okay. Because it's a fully managed classroom, Google Classroom. And I will assign this assignment to everyone. Automatically, it will be assigned whoever is in the classroom. Okay, and I will be giving enough time, like I say, okay, 3 to 4 days I'm giving, and it has suppose 10 questions, 15 questions, and those I have covered in my during the session. Okay, and you can take help from Google or anywhere, but write proper answer in your language, okay, in your proper sentence, so that you can just think about it, like when you are going for interviews or when you are going to learn something, so you can recall. Okay, and I will be doing some mock also. And these mocks I will tell, right, like 15-20 minutes mock, like randomly I can take it. Okay. So why you will be attending the session every day and properly, like like starting from the session until the end of the session you attend. So sometimes I can ask you to, like when I'll be doing some commands, right? So I will ask you, right, okay, you do show me your environment and then run this command. So you will get idea, right? Okay, okay, I have to do this, so you have to be prepared. Okay. So I will first 1 or 2 times I will find, okay, I will understand because this is a new thing. Okay. But once you will be after a 1 week or 2 weeks, so this will be regular, will be done before starting the session, like 5-10 minutes. I will be just asking some coding things or something which you have done in the previous classes. Okay. So I will start the complete. This is a 4 sections are there. Okay. The first section is a big data on premises. Okay. That is basically a part of Hadoop and Spark. Okay. Hadoop and Spark. And this Hadoop and Spark, I will cover. I will start from the big data funda. I will give the syllabus also. I have my Google site link. There is you can find the entire syllabus, the topic by topic. Okay. So I will paste this link. This is a course syllabus link. So this syllabus link, I will be starting first Hadoop fundamentals. So Hadoop architecture, Hadoop commands. Okay. So this all I will cover in the SDFS. Okay. So when we are learning big data, right? So Hadoop is the base, like it's a storage component, like large amount of data we are storing in the files in Hadoop file system. Okay. So we will do some MapReduce also. MapReduce is a programmatic part, Java coding is needed. But I'm not expecting in this, like you should be writing code, because mostly nowadays nobody is asking to write code. But theoretical point of view, understanding point of view, you should know the architecture. Okay, what is a MapReduce architecture? What is a different component are there in the MapReduce? So those theoretical way understand the concept. Okay, this Hive is very important because it's a completely a SQL tool. Hive is a SQL tool, like data warehouse tool. We know, right? SQL databases like Oracle, MySQL. So same Hive is following the SQL queries. Okay. So from here you will learn the SQL, right? So complete DDL command, DML commands. Okay. So this data modeling, right? And different types of operators, surveys. So these all part of the Hive. Okay. Another tool is a Hadoop is Scoop. Okay. So in the, if I talk about in the Hadoop, so Hadoop is not only one single tool or component. So Hadoop has the various component. So one component is SDFS. Second one is a MapReduce. So these are the two core components. So these are the two core component of Hadoop, two core components. So one is a storage component, one is a processing component. So MapReduce is a processing, but now MapReduce is replaced by the Spark. So people are using, instead of MapReduce, we are using the Spark. So nowadays, if you look at the every requirement, right? So there is a Spark case. So they are asking either PySpark or Spark Scala or Spark Java. So these are the different flavors are there. But Spark concepts are same for all different types of, whenever you'd go for PySpark, Scala or Java. So only matter of which language you know, you can use the Spark in that particular APIs language. Okay. The other Hadoop ecosystem component, Hive. Hive is a SQL data warehouse tool. Okay. These all will come in the detail. I'm just giving a high level overview. So SQL data warehouse tool is a SQL databases, right? We write a SQL queries in Hive. So Hive is using its own query language, Hive query language, and it's a SQL query, Hive query language. Okay. So, and SQL queries, we are doing all SQL type of operations. But Hive is not limited to SQL. Hive has the partitioning, bucketing. Okay, all these are the different concept are there. And Hive is handling the different file format data. We can write the data into Hive, CSV file, JSON file, XML file, and different other different types of file format data we can write into Hive table. Okay. So Hive is nothing but a SQL database tables are there in Hive, and we are querying the tables by one query interface is there, Hive CLI. So Hive CLI, here we write a SQL command like this. Okay. So we can query the tables and we can get the results. So different file formats data we can have in Hive. Okay. So mostly like CSV file, JSON file. So you understand, like JSON is a key colon value format. CSV is a comma separated format. Okay. And XML is a node format is there, like we have a tag are there, so XML tags are there. Okay. And after Hive we have the scoop. So scoop is a component. Scoop is a component which is basically providing the ingestion of the data. So when we talk about like Hadoop is a file system, having a Hadoop SDFS file system, but we need to bring the data from some external source. So how can we bring the data from external source? By Scoop. So Scoop is ingestion tool to import data from RDMS. So RDMS, like SQL databases, we call it SQL databases like Oracle, MySQL, SQL Server. So these are all RDMS tool. So when I'm bringing my data from RDMS database table to Hadoop file system, that is done through the Scoop. So Scoop is ingestion of the data for structured data. So I will talk about like what are the structured data, semi-structured, unstructured. So those will be coming in the big data fundamentals. Okay. So when I start the big data fundamental concept, I will talk about these all things. So another tool after the Scoop, there is a Flume is there. Flume is used for unstructured data and semi-structured data. So total, if I say in around the world, we have three types of data: structured data, semi-structured data, and unstructured data. So structured data is a data which has the dimension, the data which has fixed dimension. Like I say, name is there, age is there, date is there, right? DOB is there, date of birth is there, date of joining is there. So it is having a fixed dimension. And second type of data is semi unstructured data. Unstructured data which has no fixed dimension. We cannot measure this kind of data without any tool, a specific tool. So if I say this kind of unstructured data is like audio file, audio, video, images. Okay. So if you have seen, these are the different types of data which we need some processing APIs we need, right? Audio processing APIs, image processing API, video processing APIs, right? So unstructured data is a completely unstructured form, right? We cannot measure by traditional tool, right? Okay. And the third is semi-structured data. Semi-structured data, which has the characteristics of both structured and semi-structured. Like mostly the files comes in this, like CSV file data, JSON file data, XML file, or email attachment. There we have body is a like structured data, and we can say the attachment is an image, right? So that is a unstructured data. Okay. So these are the some categories of the semi-structured data. So Flume is basically used for unstructured and semi-structured data to import into Hadoop file system. Okay. So Hadoop file system is a storage component of Hadoop. Okay. So why Hadoop is used, right? We can do in a Unix file system and Windows file system. Why we need Hadoop? So Hadoop is actually designed for large data processing, right? So nowadays data size is growing every day, right? We see that if we see sometimes like a flight data. So if flight is going from one place to another place for 30-minute flight, it is generating 12 terabyte of sensor data. So this sensor data is a raw data, sensor raw data. So this data is useful for analysis of the flight, right? How smoothly flight like flew from the one place to another place, right? So we can analyze this sensor data, right? So I'm saying this 12 terabyte data is a really huge amount of data which is generated in the 30-minute. Okay. So this kind of huge data we cannot handle with the traditional tool like SQL databases, right? RDMS databases, right? So we need some Hadoop platform, right? Like some platform which can handle large amount of data. Somebody's asking question. Okay, no problem. So so if I talk about like I'm using this huge amount of data. So this huge amount of data we need to store some cluster. We cannot store on a one single machine. So if I'm storing this data in a cluster, so I need like like cluster where I can increase the number of node also. Suppose I say right now I have a 2 node cluster. Okay. And this cluster capacity is, okay, I say 2 TB and 2 TB, 4 TB data. Okay. Suppose tomorrow I get more than the 4 TB data. I want to process 6 TB data per day. 6 TB data per day. So this 2 nodes will not be sufficient. I have to add more number of nodes in my cluster. So if I'm adding a more number of node in my cluster, so it is called the horizontal scalability. Horizontal scalability is when you can add as many as number of node in a cluster. So your disk and size capacity, RAM capacity will be multiplied. Okay. So horizontal scalability, like where we can increase the number of node depending on the requirement of the data, right? So this kind of data, right, where the data is really huge, going very, very huge. So we can use the horizontal scalability, like a cluster of nodes there we can store. Okay. So far it is clear. Okay. Just I'm talking about, I will go in more details later. Okay. First, I'm just talking about what is a structure and semi-structure and unstructured data. And next component in the Hadoop is Flume, Hive, Scoop, HBase. So HBase is a NoSQL database. So we know there are the 2 types of category of the databases, like SQL database and NoSQL database. So SQL database is like vertical scalable. So only one single machine, you can increase the RAM and hard disk, but beyond the capacity, you cannot increase, right? So vertical scalability, right, at a certain limit, right, as a certain limit you can increase the capacity, certain limit. Okay, certain limit we can increase the capacity in terms of CPUs, memory, and disk. Okay, so these are the 3 major component, right? If I say CPU, memory, and disk. Okay, but in NoSQL, the advantage is like it's a horizontal scalable, right? If I want to share the data across the node, we can share. But SQL databases, like in one system you install Oracle, the second machine, like you have a different Oracle machine, you cannot share the data across the node, right? But NoSQL database are horizontal scalable, same like Hadoop, horizontal scalable. So horizontal scalability is there, and horizontal scalability, like we can add as many as number of machines. Okay, and where NoSQL is installed, and data can be shared. Data can be shared across the machine. Data can be shared across nodes. Okay, in NoSQL database. So we will see some NoSQL database categories are there, right? We have MongoDB is there, Cassandra is there. Okay, some cloud services also providing the NoSQL database, like DynamoDB is there. It is in the AWS cloud. Okay, so these are the some, and in the GCP has, okay, there is a BigQuery is there, Bigtable is there. So Bigtable is a NoSQL database in the GCP. So when you will go through these services, you will come to know these are the NoSQL databases, like which are the giving advantage over the SQL database. Okay, so HBase is a NoSQL database of Hadoop ecosystem. Okay, so these are the Hadoop ecosystem component we gone through it, like Hive, Scoop, HBase, Flume. Okay, so these are the NoSQL. These are the all Hadoop ecosystem component. Next is our Spark. Okay, so Spark, once we come to the Spark, so these are all topics in the Hadoop ecosystem common. So Spark, we will be starting with the Spark core. So this is the basic core fundamentals of the Spark core. Then Spark SQL, Spark streaming, and different integrations are there with the Spark. So we can integrate Spark with MySQL, Spark with MongoDB, because Spark is a processing engine. But how this Spark is reading data from the source and how it is writing data to the target. So Spark integrations we will be doing through the different data sources and same different data targets. Okay, so these are the different data storage we are connecting with the Spark, like MySQL, Mongo, Snowflake, Elasticsearch, Kafka also we can integrate, HBase we can integrate. So these all we will see in the Spark. Okay. So Spark, first we learn the Spark fundamentals, like Spark core concepts of the Spark. There is a transformations are there in the Spark, right? They are the transformation and action. So transformation is nothing but conversion of the data from one form to another form. So these things will come in all details. Okay. Slowly. Spark SQL is basically reading, writing data to the different data sources. So this is a part of the Spark SQL. And Spark streaming, where the data is coming as a streaming data. So what the disadvantage we get it in MapReduce, like we go over the Spark. So MapReduce is only batch processing data. So it cannot process the not for real-time data. So there are two types of data processing. One is a batch and another one is a real-time processing. So batch processing is, right, suppose I have some historical data I have, like 10 years historical data. Okay. So historical data for anything, like I say example, weather forecasting. Okay. So weather forecasting data I have. Okay. And this weather forecasting data, 10 years historical data I have. And I'm going to process the data and doing the analytics on top of the data. I want to find max temperature or like whatever is related to weather, I can do the analytics. But suppose if I want to say some real-time streaming data I want to do. So what type of real streaming I say, suppose the data is coming from the Twitter. Data is coming from the Twitter like hashtag. Okay. And this Twitter hashtag data, I want to analyze and then do some sentimental analysis, right? I want to do some prediction. I want to do some real time. And another real time streaming data example is like live cricket match streaming, right there, live cricket match streaming. And other example is there, I can say credit card swiping, right? So credit card swiping is like I want to do the fraud detection. Okay. These are the some use cases for the real time. So real time means the data is coming on the fly. The data is not already exist. So data is coming on the fly and that data is called the real time data. So Spark is basically having both batch and real time. So MapReduce is only batch processing, but Spark is having batch and real time streaming. So that is the reason the MapReduce is not having the productivity, right? If MapReduce, I'm writing a code, I'm writing a 200 lines of code for simple word count program, very simple word count program. And the same program, same code, if I want to write, same use case, if I want to write in Spark, I will writing a hardly 3 lines of code. So the productivity is great because mostly Spark I'm using a libraries, right? APIs. Okay. So that will be making it my more productivity in the Spark, and the execution is much faster. So if I say Spark, you heard about Spark is 100 times faster in memory. So in memory means like it's processing the jobs in the memory, it's 100 times and 10 times faster in the disk. So even though it is using the disk processing, okay, even though it is using disk processing, that is also 10 times faster, 10 times faster than the MapReduce, 10 times faster than MapReduce. Okay, so these are the key differences, like why the Spark got popular and why Spark is the Spark main concept is a in-memory processing. In-memory processing is a real-time processing, like it can do the processing in the memory itself. So for Spark, the configuration should be very high. So the main constraint with the Spark main constraint is memory. Okay, so you are processing the entire data in the memory itself. You are not writing back to the disk for intermediate processing. So main constraint for the Spark is the memory configuration should be very high. Okay, should be high or very high depending on the use case, right? But memory constraint is not a big deal because we can increase as much as memory possible, right? Because if we have a very high configuration systems we have in our cluster, then we can process very large amount of data with the high processing speed. Okay, so Spark, we will see all this concept. Okay, and next one is we will come to the cloud. Okay, so cloud and DevOps, there are the two parts are there. So cloud is basically the main concentrate we do AWS cloud, but I will cover some part of the Azure also. but we have to focus one cloud first so that people can understand, like at least one cloud they can show confidently, and other cloud you can show like you have some services knowledge you have, but main concentration is the AWS cloud. Okay, even Azure cloud also you can show, but Azure cloud, the few services we can do, not the entire cloud. Okay, because if I do the same thing in AWS, everything is repeated there in the Azure. Only the services doing the same thing, but the different services and names are different. So AWS is having a EC2 is there, that is a machines, right? We create a virtual machines in EC2. In AWS, we have a S3 is the storage, file system storage is there. And there are some other services like AWS Glue is there, AWS Lambda is there. Okay. And DynamoDB is a NoSQL database. Okay. And RDS is a SQL database services there. And some other services are also like we have a EMR. EMR is a very important service, that is Elastic MapReduce. This is the same, whatever Hadoop Spark we are doing on premises, we will be doing in the cloud by using the Elastic MapReduce. But Elastic MapReduce is the managed services and paid service, managed and paid service, right? So like we have to learn, because the companies can bear this managed services. Okay, so this services cloud is there. And next is a DevOps. So DevOps, we need to know basic fundamentals of the, like Git, we know, right? We have to code check in, check out, right? We should know Git, we should know Jenkins. So Jenkins, these are automation pipelines. Basically, we can schedule our jobs, right, by using build process and deployment process. So build and deployment process by using the Jenkins, we can do build and deployment process. Okay, and some containerization tools also there, containerization tool. So Docker, Kubernetes are the containerization tool. So we should have the knowledge, fundamental knowledge, right? How can we set up Docker, Kubernetes pipelines, and how can we run our applications, right? And so whatever we have done on premises, same things can be done on the containers. Okay, we don't need to install, and step by step we don't need to install. The container is a quick and very easily we can get containers, and it's a lightweight. Okay, so there are some advantages are there on the containers, but we cannot directly start the DevOps tool. We have to understand complete from the scratch, right? What are these tools work alone, right? Okay, how Hadoop tools, a Hive, Scoop, HBase, okay, Spark, and then when we move to the cloud and DevOps, then we understand how many tools we have used here, how can we install on the containers. Okay, so this complete setup things we will be doing in the Ubuntu. Okay, so Ubuntu, how to bring an Ubuntu in our local system. So we have Windows machine. So Windows machine, we have to install VirtualBox, and this VirtualBox, Oracle VirtualBox. This is Oracle VirtualBox. So I will share the document and installation process. Right. So once you install the Oracle VirtualBox, on top of that, you have to install Ubuntu 22.04 or 23.04. And once your Ubuntu is ready on your VirtualBox, then we will be installing manually all these tools. So Hadoop we have to install, Hive we have to install, Scoop we have to install, okay, and HBase, Kafka, Spark, everything will be coming installation manually, okay. And once this cluster will be ready, so all we will not install together, because we will install one by one, right? Okay, so when we are going to start the Hadoop and Hive, so we'll install Hadoop and Hive. Then we are going to install Scoop. So these are very pretty small installation, not too much big time it will take. Okay, so this installations like will be giving you the idea how to install manually these tools in Ubuntu. Okay, so you don't need to depend on any cluster lab. You don't need to depend unless we want to go to the cloud. When we are going to the cloud, then we have need a cloud, right? But before cloud, we can practice in our on-prem, right? We can prepare our cluster. But in the companies, you will find mostly they use either cloud version they are using. So AWS cloud, they are using either EMR for the Hadoop Spark. Okay, if they are using Azure Cloud, so they have HD Insight is there. So HD Insight is a service which is providing the um, Hadoop Spark, and if it is a GCP cloud, so there is a Dataproc. Okay, and if we are using on-prem cloud, so there is a Cloudera is there. So Cloudera is the one. Okay, so mostly the Cloudera is a top leading company, right? The people are using Cloudera. Okay, so Cloudera is supporting nowadays. Cloudera is on the AWS cloud. Okay, also. So Cloudera, the on-premises Cloudera now is on AWS Cloudera. Okay. So internally, this Cloudera is using internally AWS Cloud, internally using AWS Cloud. So what is the advantage of going on the cloud, right? We are talking about why we are not on premises. The advantage is like cloud is shareable, right? We can share our third party vendors are there. Those are sharing the data to us, or we are sharing the data reports to them. So how can they access, right? If on premises cannot access outside the network, outside network you cannot access, outside network we cannot access. Okay, but nowadays the cloud, like hybrid cloud is there. So hybrid cloud, the advantage is public and private, right, together in a one single cloud, that is hybrid. So public cloud, they keep it for their vendors to publicly share the data, and private they keep it for their own work, for their own infra. Okay, so they kept it on the private, but public they keep it for the external vendor. So for external vendor who can access their reports and everything, they can access through a public network. Okay, so that is the reason the cloud is now hybrid. So hybrid cloud is there. So hybrid cloud is a combination of your public and private. Okay, so there is a way, right? There is a BPC is there, virtual private cloud in AWS. The service name is a BPC. So you can create your own public or private cloud infrastructure you can create. So depending on the requirement, you can decide. Okay, so this setup we will start. Okay, first we will start tomorrow the big data concepts. Okay, big data concepts we start. Okay, I can do one thing. I can give my YouTube channel also there, my previous batch classes also there. So before starting the session, you can go through those concepts in the advance, like what I'm going to cover. So it will give you the help, right? You can like in the session, like if you have any question you can ask, or you can like before I do something, you can do before that. Okay, so I will paste the link of the my YouTube one there, the um like from the big data fundamental concept, so you can start. Okay, see, it's your capacity, you can do as much as do. If you find the material, you can prepare your own. I'm saying like you can like some advanced concepts are there. If you think okay, you have to learn fast, or you can do your own and you can ask personally that query to me. Okay, but in the batch I want to go proper speed, and I want like everyone should feel okay, and then I will go to the next topic. So is it okay, right? Everyone like will be with the same like, but I want all of you guys output, right? Okay, you are feeling like it's a speed, or like it's a, you can easily, you are able to understand. So you can give me the feedback in the group. Okay, like something you feel like some of them are like some of people are right non-background technical background. So I understand it is not quick to learn, because sometimes the people take 2 3 times to repeat the same thing. Okay, so I feel you can spend more time in that scenario, because if the things are becoming complex to you and you are thinking okay it is taking, so you can repeat. And even though also you are not feeling to understand, like you want to repeat, I can repeat the concept. Okay, anything else like you want to ask anything? So tomorrow I will start from the big data concepts. I will put all the links, classroom link, everything. I will put it in the group. Mm. Everything is good. Okay. So I will share the classroom link. Okay, so you can join that classroom link. Okay.
Okay, Arvind.
Okay.
Yeah. Thanks everyone. Okay. Thank
Thank
you.
you.
Thank you.